So at this point, we've learned these two relationships, that 1 mole is equal to 6.02 times 10 to the 23rd atoms, and that 1 mole is equal to the molar mass. And we find the molar mass by using the periodic table. And if we have something that's a compound, like H2O, we would have to add 2 hydrogen masses and 1 oxygen mass to get a total molar mass of 18.01 grams. So I can think about these problems using this image. I like to call this mole island. I know that 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules or particles. I also know that 1 mole is equal to the molar mass of the material, and 1 mole, if it's a gas, because gases are so light, is equal to 22.4 liters in volume. This mole island can be used kind of like a road map. If I am given a number of moles and the question asks me for atoms, I know I can use this relationship right here. That 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules. Or if I'm given a number of atoms or molecules, I can get over to the mole island because I know that relationship. If I'm given a molar mass and I need to find out the number of moles, I can use that relationship that I know, or I can go the opposite direction and use that relationship. The same goes for moles and volume. If I'm given moles and I need to know volume, I can use that relationship. Or if I know volume and I need to get to moles, I can use that relationship. So these are the ratios that we use. If we are going from moles and we want to find out how many atoms we have, we're going to start with our number of moles that we're given. So let's say we start with 2.2 moles. And we're going to use this conversion factor right here because we want moles on the bottom so that moles cancels out, and that leaves our answer in atoms. So we are converting from moles to atoms. If we're going the opposite direction, for example, if I say that I've got 1.2 times 10 to the 25th atoms, and I want to know how many moles I have, I'm going to be going this direction. I'm going to have to use this relationship here. The reason I'm going to use this relationship is because I'm starting with atoms, so atoms goes on the bottom so that my units of atoms cancels out, and that means my answer is in moles. So I'm converting from atoms to moles, and so I use this as my conversion. If you don't like the method of starting with your units and then canceling out your units, of setting it up like this, if we want to get to atoms, and you don't like this method, I will go over how to do the ratio method at the end of each. So instead of using conversion factors, a lot of students want to memorize that if I'm going from 1 mole to atoms, I'm going to multiply by 6.02 times 10 to the 23rd, or if I'm going from atoms to moles, I'm going to divide by 6.02 times 10 to the 23rd. And here's the reason we don't want to memorize. The reason we don't want to memorize is because soon we're going to have an understanding of all these relationships. We're going to be starting with molecules of one material, and we're going to be trying to figure out how many molecules of a different material. So you would have to memorize whether you multiply or divide when you're going this direction and this direction, and then if you multiply or divide for this, and then if you multiply or divide for this. This is a lot to memorize. So we don't want to memorize it. We want to understand how to use our conversion factors. So let's take a look at all of these conversion factors. If I start with 1 mole, and I want to get to molecules, I can take this road and use this relationship. Again, I'm starting with moles, so moles goes on the bottom so that they cancel out, and this unit on top is my atoms. That's going to get me to my atoms. If I'm starting with atoms and I want to get to moles, my unit of atoms goes on the bottom and my unit of moles goes on top so that atoms cancels out, and now I'm converting to moles. What about if we want to go from moles to mass? In that relationship, 1 mole is equal to the molar mass of the material. 1 mole we don't want anymore, so moles goes on the bottom so that it cancels out. And mass goes on the top so that that's the unit I'm getting to, since I want to go from moles to mass. If I'm going the opposite direction and I'm starting with mass, my mass of 1 mole is going to go on the bottom, the molar mass, so that that cancels out, and my answer is getting me to moles. And if I'm using a gas and I want to go from moles to a gas, there are 22.4 liters in 1 mole of any gas. That's a volume. So my 1 mole is going to go on the bottom so that moles cancels out, and I get my answer in liters. If I want to go the opposite direction, then my liters is what I'm starting with, so liters goes on the bottom and moles goes on the top. That means that now my liters is going to cancel out, and my answer will be in moles. If you'd like to, pause the video here and write down this roadmap for yourself. It can be helpful when doing practice problems so that way you kind of basically get it down. And it really is a roadmap. If you're starting with moles, I can only go to atoms, or I can go to mass, or I can go to liters. If I start with something like atoms and molecules, and my question wants to know grams, notice that there's no roadmap here. There's no road in between those. There's no relationship that we have. And so we have to actually do more than one step to solve a problem like that. If I am given my atoms or molecules, I'm actually going to have to follow this road here, and then I find out my moles, and then I can take this route here and get to my mass of that material. So pause it if you'd like and make a note for yourself. Use it as you're doing practice problems. So here we go. We've got some practice problems. I like to point out what I'm given. I know moles, 1.3 moles, and I want to find out how many grams. So I can look at my road map here. I'm given moles, and I want to find out my grams. So I'm going to be following this road right here. I'm going to write down my moles that I'm starting with, and then I'm going to put 1 mole on the bottom, and I'm going to use this conversion factor right here. So I'm starting with 1.3 moles, and according to our roadmap, 1 mole is equal to the molar mass of carbon dioxide. So I've got to go on my periodic table and calculate my molar mass of carbon dioxide. So the molar mass of carbon dioxide is 44.011. So I'm taking 1.3 and I'm multiplying it by 44.011 over 1. Keep in mind that any number over 1 is simply itself. So I can almost ignore that. So 1.3 times 44.011 will give me my answer of 57.21 grams. And I now know how many grams are in that many moles. Let's take a look at this next problem. Notice that it says we're starting with grams this time. So we're starting right here on our roadmap. And this time we want to find out how many moles we have. So we want to get here. That means that we have to take this road right here. We're going to start with our mass, and we're going to put the molar mass on the bottom and 1 mole on the top. So if I start with 28.3 grams of carbon dioxide, I don't want grams of carbon dioxide anymore, so that molar mass of 44.011 goes on the bottom now. And I know that 1 mole of carbon dioxide has that mass. That's the relationship. It's always 1 mole is that molar mass. So now I'm multiplying across, and there's nothing underneath here. This is like a 1, and I'm multiplying it across. So 28.3 over 44.011 is the math I'm doing as I multiply across. So if I take 28.3 and divide by 44.011, I find out that I have 0.643 moles of carbon dioxide. So let's talk about how to do the ratio method. Remember that we're multiplying. Here's how the ratio method works. If I've got 1.3 moles and I want to know how many grams I need, I can simply set that equal to 1 mole is equal to the molar mass of the material, which we calculated as 44.01 grams. With the ratio method, the only thing you need to remember is that whatever unit's on top goes on top, whatever unit's on bottom is also on bottom on this side. And then we just use our basic algebra to solve for this. We cross multiply and solve for our x. So x times 1 is simply x, and we set that equal to 1.3 times 44.011, and we get that our answer is 57.21 grams. So this right here is the ratio method. We're cross multiplying because we're setting them equal to each other. So I want to make sure that you're kind of seeing that this is an equals sign in here versus we're multiplying what we start with times this conversion factor. So if I did the other problem, this same method, again, I'm starting with 28.3 grams of CO2, and I want to know how many moles I have. So I put the moles on the bottom as my x. I know that 1 mole is equal to 44.011 grams. So again, I'm going to cross multiply. So 44.011x is equal to, I'm going to cross multiply 28.3. Isolate your x by dividing both sides by 44.01. X equals 0.643, and my answer is in moles. So that's the ratio method. Let's try 2 more problems. Pause it before I show the answer. I always, again, identify I'm starting with 2.2 moles, and I want to get to molecules. On the other problem, I'm starting with 8.3 times 10 to the 24th atoms, and I want to get to moles this time. So you can use your roadmap, lay it out for yourself, pause the video, and then come back and check to see how you did. Here's my work and my answer for the first one. Notice I'm starting with moles, so my relationship of 1 mole equals 6.02 times 10 to the 23rd molecules. Moles is what I start with, so moles goes on the bottom. So mathematically what I'm doing is I'm taking 2.2 and I'm multiplying it by 6.02 times 10 to the 23rd, because this number is just over 1 and over 1. Any number over 1 is simply, divided by 1 is simply itself. So you get 1.32 times 10 to the 24th molecules. For the second problem, I'm starting with atoms, so I'm using that same relationship, but this time my atoms goes on the bottom because I want atoms to cancel out. And my moles goes on the top. And so this time, if I take 8.3 times 10 to the 24th times 1, and then there's an imaginary 1 here, I'm taking this number and I'm dividing it by this number. And you get 13.8 moles, okay? So atoms cancels out, moles is what my answer is in then. Here's the ratio method on this one. If I start with 2.2 moles of CO2 and I want to know how many molecules that is, I'm going to set that equal to the fact that I know that 1 mole is 6.02 times 10 to the 23rd molecules. Cross multiply, 1 times x is x. 2.2 times 6.02 times 10 to the 23rd is 1.32 times 10 to the 24th molecules. Again, this is multiplying this number by this conversion factor so that moles cancels out and my answer is in molecules. This you cross multiply. So if I do the next one, 8.3 times 10 to the 24th atoms, the question wants to know how many moles is that? Well, I know that 1 mole is 6.02 times 10 to the 23rd atoms. So cross multiply, 6.02 times 10 to the 23rd x is equal to 8.3 times 10 to the 24th. Divide both sides by 6.02 times 10 to the 23rd to isolate my x. And x equals 13.8 moles. Okay? Again, you get the same answer. It's just a different method. What if we've got something that's a little bit tougher? Here I am given a number of atoms, and I want to find out how many grams I have. So the first thing, let's look at our roadmap. If we are starting with atoms, and we want to get, I'm starting here, and we want to get to grams, again, notice there's no roadmap. So what we actually have to do is we have to first follow our roadmap from the atoms we're given to moles, and then we've got to use the moles in order to get to our mass. So let's try that. We're going to start with atoms and we're going to get to moles. So that's our first step. We're going to start with 3.8 times 10 to the 23rd atoms, and we want to get to moles. And we know 1 mole is 6.02 times 10 to the 23rd atoms. So atoms is going to cancel out, and my answer is going to be in moles. But I don't want moles, I want grams. So we need actually another step here. We need to realize that 1 mole is equal to the molar mass of 44.011 grams of CO2. So now moles is going to cancel out, and now my answer will be in grams. So we can follow our roadmap and see each of those different steps. Here was the first step, and here was the second step that we did. So we're going to take this number, multiply across by 1, so it's still just itself, multiply by 44.011. So we're taking 3.8 times 10 to the 23rd, and we're multiplying it by 44.011. And then on the bottom, there's like an imaginary 1 here, multiply across, and then there's another 1 there. Well, any number times 1 is simply itself. So here's what we're putting in our calculator. We are actually putting into our calculator 3.8 times 10 to the 23rd times 44.011, and then we're going to take that answer and we're going to divide it by 6.02 times 10 to the 23rd. Put that in your calculator, see what you get, and you should get somewhere right around 27.8-ish grams of CO2. Let's take a look at the next problem. On this next problem, I've got 32.8 grams, so I'm here, and I want to know how many atoms I have, so I have to get here. So it's the exact opposite. I have to get from my mass to my moles, and then I have to get from my moles to my atoms. So if I set this up and follow that roadmap, I've got 32.8 grams of CO2, and 1 mole of CO2 we know is 44.011 grams of CO2. So I'm getting rid of my grams of CO2. So I'm starting at grams and I'm headed this way. So now my current answer at this point is in moles, but I don't want moles, I want atoms. So now I got to do my next step. I know that 1 mole is also equal to 6.02 times 10 to the 23rd atoms. So now moles cancels out, and now my answer is in atoms. So again, multiply across. So I'm taking 32.8 grams, multiplying it by 6.02 times 10 to the 23rd atoms, dividing it by, multiply across, just ones down there with my 44.01 grams. Put that in your calculator and see what you get. And you should get somewhere pretty close to 4.5 times 10 to the 23rd atoms. I can still use the ratio method with these tougher problems as well. If I start with 3.8 times 10 to the 23rd atoms, and I want to know how many grams that is, we can simply remember that our 6.02 times 10 to the 23rd atoms is equal to the molar mass. Well, the molar mass is 44.011 grams. Because remember, this number of grams is 1 mole. 1 mole is 6.02 times 10 to the 23rd molecules. So that means that that molar mass is equal to 6.02 times 10 to the 23rd atoms. So I cross multiply. 6.02 times 10 to the 23rd x. I cross multiply, set that equal to 3.8 times 10 to the 23rd times 44.011. Isolate my x. Whatever I do to one side, I have to do to the other. X is equal to, I still get the same answer. I can do the same thing for this problem as well. That's just another method, is the ratio method. If you're starting to understand this roadmap, I can actually make your life a little bit easier. Remember the first problem that was 3.8 times 10 to the 23rd atoms? We started right here, and we're trying to get to grams, so we're going here. And we know these two relationships. We know that 1 mole is 6.02 times 10 to the 23rd atoms, and we know that 1 mole is the molar mass of the material. Well, if 1 mole is equal to 6.02 times 10 to the 23rd atoms, and 1 mole is equal to the molar mass, which for, this is CO2, was 44.011 grams, then that means this many atoms has this much mass. That can actually be pretty helpful, because that means that I could actually put this all into one step. Let me show you how. If I've got 3.8 times 10 to the 23rd atoms, and I don't want atoms anymore, so it's going on the bottom. What I do want is grams, so I'm going to put grams on the top. Well, what's my relationship between atoms and grams? I don't have a road right here, but what I do know is that I can put these two road maps together. Because if 1 mole is 6.02 times 10 to the 23rd atoms, and 1 mole is 44.01 grams, well, that means that if I've got 6.02 times 10 to the 23rd atoms of carbon dioxide, I've got to have that many grams, 44.011 grams. Because 1 mole, these are equal to each other. So I can actually multiply across, and you should notice that this is exactly the same as the work on the previous slide. So I took a screenshot. Here's the work from the previous slide right here. I'm outlining it in green. Same problem. How many grams of CO2 are in 3.8 times 10 to the 23rd? How many grams are in 3.8 times 10 to the 23rd atoms? Here's the two steps that we did previously. We set up this ratio and then this ratio, And here's what our math looks like. That number times that number divided by 6.02 times 10 to the 23rd. Well, we did it a little bit easier. We combined it, because if 1 mole equals 6.02 times 10 to the 23rd atoms, and 1 mole equals the molar mass, well then the molar mass equals that number of atoms. So I can go ahead and use that, and notice how the work here is exactly the same as the work right here. Same work, same work. So in conclusion, these are the 3 relationships we've learned. We can either start with what we're given for our units, and we can use the conversion factor, and we put our given units on the bottom and what we want to get to on the top, and we simply fill in the numbers depending on what we're doing. Or we could use the ratio method, where we start with what we're given and we put it over our x of our unknown, and then we set that equal to one of these ratios depending on what our units are. Whatever units are given, we're going to use that relationship, and what the relationship is with the unknown goes on the bottom. Those same units. And we now know that we can actually combine, since 1 mole is equal to this number of atoms, and 1 mole is equal to molar mass, and 1 mole is equal to 22.4 liters. Well, that means if I've got this many atoms, I have the molar mass of the material. So we now know another relationship. We now know that 6.02 times 10 to the 23rd atoms or molecules is also equal to the molar mass of the material. Or 22.4 liters is also equal to 6.02 times 10 to the 23rd atoms. Or the molar mass of the material is equal to 22.4 liters. If 1 is equal to 1 is equal to 1, well then this guy is equal to this guy, and this guy is equal to this guy. I hope this helps. Make sure to do some more practice problems. Trust me in that practice is going to make perfect on these.